So last time we talked about how to graph sine and cosine functions, and we talked about what the A factor represented. We talked about the fact that that was amplitude, and the sine of A gives it a reflection. What we also said was the sine and cosine have a period of how much? How many pi? 2 pi. They have a period of 2 pi. And we said that for the default, right, that the sine and cosine start at 0 and they end at 2 pi. Okay, now, it's possible, right, that the period of a specific function can change. All right, so not every single sine function has a period of 2 pi. That's just the default. But things change. And why would they change? Because, take a look. If you have a sine function like this, right, starts at 0, ends at 2 pi, that's one type of wave. That's one wave. You might have another one that starts and ends at pi. So that's a much quicker wave, right? It's a much, if I continue that way, look, that's a much quicker wave. Do you see that? Right? You might have one that starts at 0, and if this is 2 pi, it goes on for longer than that. That's a much slower wave. And what's the difference between all these waves? The length of the period. And also, if you have a wave that is much quicker, it might be a completely different type of wave. For example, something like this might be a radio wave, right? That might be a signal that's transmitted from a radio station over to your radio in your car. Something like this red one here might be a microwave. Okay, something that's even quicker might be a gamma ray. It could be an X-ray, right? And they, in physics, they have completely different properties. A radio wave, nice and slow, is completely harmless. A gamma ray would kill you, right? Same exact sine wave, but the periods are different. Okay, so let's see how we deal with periods. Okay, so we said that the equation for a sine or cosine looks like this, where we had variables A, B, C, D. A represented what? The what of the wave? The amplitude. Okay. B is responsible for the period. Okay? B is responsible for the period. So now, if I have a random equation, if I'm walking along the street and on a billboard I see an equation of a sine function, I can look and I can figure out what the period is instantly. The way I can do that is this. Period is always 2 pi over b. Why 2 pi? Because the default period of the sine is 2 pi, so you always do 2 pi over b, and that's the period. B is always positive. It's the absolute value of b. Okay? So take a look here. So take a look at this function. F of x is sine of 2x. And I want to find the period. It's 2 pi over this number b. That's b. Right? So that is just pi. All right? So the period of that function is pi. All right, so what about the next one? What's b in this function, b? 3. This is b. So the period is going to be 2 pi over 3. And if you can't simplify, then it's just 2 pi over 3.
So it's the same for cosine?
Oh, did you get the wrong packet?
I think it was on the same page.
Okay. All right, the next one. Which one is b? What's b here? 1/2 is b. So the period, look, the period is 2 pi over 1/2. No, The 2's don't cancel out. So this is 2 pi times 2 over 1, right? So that's 4 pi.
So what do you, like, when it says like -2?
So the negative 2 here, that's A. That deals with your amplitude. Okay? Right now we're just focusing on period. All right. B here is what? Right, B is 1/5. So the period is 2 pi over 1/5, 10 pi. Okay?
So the lower the number is, the longer it's gonna go.
Yes.
Okay,
Good.
it's just like parabolas.
Yes.
Right? Okay.
Yes. So we have an observation here. He's saying the lower the number is, I think what you mean is if B is less than 1 but greater than 0, right? If it's a fraction between 0 and 1, the period is going to get longer. And if B is greater than 1, okay, so this is going to be a longer period. If B is greater than 1, we're going to get a shorter period. All right, so here, B is 0.25. Okay? Okay, so, right. So that's also a fourth. So, period is 2 pi over 1/4, 8 pi. Okay, now, this one might often throw some students off. So here the period is 2 pi over, what's B here?
3 pi.
3 pi. And, often students are like, but the pi's cancel. It's okay. It does not have to have a pi in there. So the period here is 2/3, and that's just fine. It can have a pi. It could not have a pi. It's actually easier like this because, it goes like by numbers, not in, right. Okay. So now that we know how to figure out a period of a function, let's talk about, okay, so let's talk about how to graph one of these, all right? Okay. So here we go. We call these graphs with horizontal dilations. Earlier we graphed ones with vertical dilations. Now these are horizontal dilations. All right. So describe how the graphs of the following functions are related. So what's changed between between f of x and g of x? Yeah.
That sine is instead of sine of x, sine of half x.
Right, and what does that mean? What of it has changed?
The b or the period.
B has changed, which in fact changes the period, right? So, and based on what Brennan over there said earlier, if B is a half, does this have a longer period or a shorter period? Longer period, right? So here, B is a half, longer period. Okay? All right. So here, I mean the period of g of x, right? But what we're going to do first is, let me graph f of x first, right? So f of x is simple old boring sine of x. It starts from 0, 1, 2, 3, 4 to 2 pi. You guys are like experts at this now, right?
Yeah, you got it.
Yeah. And if this is, whoops.
I spread mine out a lot.
That's completely fine. But you know what? In this case, since it's got a longer period, you're not going to have too much room.
You're right.
Yeah, let's do it this way. So, so this is what our sine of x looks like, right? This is f of x. Is that right? This is what you did all night for the homework. Okay. Now, g of x, okay, has a period of half x. I'm sorry, it has, the b is a half. So here is how we figure out the starting and the ending point. For f, it was easy. It's always 0 to 2 pi. Here's what we do. Default, okay, so first let's figure out the period. It's 2 pi over 1/2, which is how much? 4 pi, good. So now here's what we do. The default sign goes from 0 to 2 pi, right? So I do this, 0, boom, boom, 2 pi. Where did I get 0 and 2 pi from? This is the default of the sign, okay? Now, inside, I put that. Everything that comes after the sign before a plus sign. Okay, so there, I put 1/2x, yes. Now, I need to solve this for x. And we're going to think back to our algebra days. And this one, if I want to solve this for x, I need to multiply by 2. So when I multiply this by 2, I multiply this by 2 and this by 2. So, you know, oh, it's like, it's Thursday. It's Throwback Thursday. We're throwing back to Algebra 1. All right? This is 1/2 x, 1/2 times x. So I need to multiply by 2 to get rid of it. Okay. Now, in order to keep the equation balanced, every single term must be multiplied by the same thing. So now I have 0, x, 4 pi. So my graphing region is 0, x, 4 pi. You know what this tells me? This tells me the start and end of the new g of x, right? The start and end of my default sign was always 0 and 2 pi. When the period has changed, I need to figure out the new beginning and the new end. And this is what gave me that. So now, g of x is going to go from 0 to 4 pi. 0 to 4 pi. So 2 pi, 3 pi, 4 pi. I'm going to tell you the next one. We're just going to graph one function, and I'm going to tell you how to do it. So this one's going to go until 4 pi. Okay? So now, from 0 to 4 pi, what's the middle? 2 pi. What's the middle from 0 to 2 pi? Pi. What's the middle from 2 pi to 4 pi? 3 pi. So now, look at how this is going to look. We start at the 0 again, go up to the maximum, 0, down to the maximum, 0. Okay? The next one, we're only going to graph one function, and it'll be a lot less confusing. So, what I want to get at is this. Look at g of x and look at sine of x. They have the same shape. The difference is g of x is much lazier, I want to say. He's more kickback. It takes him 4 pi to complete one cycle, whereas this guy, f of x, he's done in 2 pi. That's the only difference. Physically, it could be the difference between hitting a C or a lower note, right? Like a middle C or like a lower note, a B or whatever, right? Okay, this has a lower frequency. Okay, this could be, the black is a higher octave if you want to think about it. That's a lower octave if you want to think about it. Okay, yeah.
I saw that between the 3 and the 4 pi, you did put a.
Yeah, and we're gonna do the, yes. Okay, let's do another one, and this time we're only gonna graph one function. So take a look. Here is cosine of 3x. The period we all know by now is 2 pi over 3. Okay. Okay, the graphing region, we go 0 to 2 pi, and what do we put in the middle?
3x.
3x, huh? So what you missed when you weren't here is the period is always 2 pi over this number. Okay? All right.
So if it's only 3x, 2 pi with or is that?
Yeah, we don't take the x. We just take the number in front of the x because that's b. It's b times x. We just take the b. Okay, divide by 3, divide by 3, divide by 3. 0, x, 2 pi over 3. So my graphing region is 0 and this. Okay, hang on. Yes.
So it's basically saying 0 and then what you found for the period.
Okay, so that was going to be what I'm going to tell. Yes. Okay, so look. This starts at 0 and ends at 2 pi over 3. What is the distance? 2 pi over 3. Okay? That's the thing. That's a thing. That's how you need to check yourself. This distance from beginning to end has to be the same as this. Now here's the deal though. Only in the most boring of functions does this start from 0. Sometimes this might start from negative 7 pi over 6 and go to 11 pi over 3, right? So it's not going to be that obvious every single time. But I'm so glad that you guys caught it because that's what I was getting at. That the distance from beginning to end must be the period. That's what the meaning of all this is. Okay, so now here's how we're going to do this. This is what requires pretty close attention now. We start from 0. And we're going to go over 4 spaces again. And I'm going to spread it out like Brandon likes to do. 1, 2, 3, 4. This is 2 pi over 3. Now we're going to do some color coding. Okay? We need to find midpoint, midpoint, midpoint. All right. So first I want to find this. Okay? This is the midpoint between 0 and 2 pi over 3. Another throwback Thursday. Back in geometry, you learned to find midpoint. You add the 2 points, divide by 2. Good. Yeah.
So confused. So why did you put 5 points?
Red mark is the midpoint between 0 and 2 pi over 3. So what I do is I take 0 and 2 pi over 3. I add them and divide by 2. That means divide by 2. So that will be half of 2 pi over 3. The 2's cancel, and that's pi over 3. Okay. Now, let me do one more. Now I'm going to do the blue here. So let's figure out what is that the midpoint of. That is the midpoint of 0 and pi over 3. I take those two, 0 and pi over 3. I add them and I divide by 2. So that's half pi over 3. Multiply the top, you get pi. Multiply the bottom, you get 6. So that's pi over 6. Now, for this green one, I love my color coding when it comes to this. Okay, so the green one, you need to figure out what is that the midpoint of. That's the midpoint of the red and the black. Pi over 3, 2 pi over 3. Whatever it's the midpoint of, I add them. Okay, so it's the midpoint of these two. I add them and I divide by 2. Yeah, there's some math involved. So this is going to be 1/2 of 3 pi over 3. How much is 3 pi over 3 these days? 1 pi. So this is 1/2 pi over 2. Notice, in doing these with the colors, there is no trig. That's all pre-algebra. Okay, adding, dividing by 2. Now I got my 5 points. Believe it or not, the hardest part of this problem is now over. Okay? At the 0, I put up my y-axis. Okay, now I go back to what you were doing last night on the homework. I'm graphing a what, sine or a cosine? Cosine. Does it start on the axis or higher up? Higher up. Where does it start? At 1. And then you do the same thing. You put your points. 1, 0, minimum, 0, maximum. That looks like a horrible cosine. No, it's never going to look different. The difference is where it starts and where it ends. Yeah, no, it's shorter. The whole thing was finished over 2 pi over 3. So if you like, so if this is pi over 2, look, if this is pi over 2, pi is here. 2 pi is here. So normally the cosine would have looked like this, right? Normally that's what the cosine would have looked like, from 0 to 2 pi, but we finished it between 0 and 2 pi over 3. Okay, let's do one more. 2 cosine 2x. The period is 2 pi over 2, just pi. So that means it's not going to go from 0 to 2 pi anymore. It's going to finish in half the time. So 0, 2x, 2 pi. Divide by 2, divide by 2, divide by 2. 0, x, pi. What's the distance between the starting and the ending? No, here. Yeah, but from here, from 0 to pi, what's the distance? Pi. Is that the same as the period that we got? Yeah. Yes, so we're on the right track.
Is the last variable always the match with the period in the graph?
Yeah, you always use this, that number 2, right in here, the second 2, to figure out your period. Okay, so this is going to go from 0, 1, 2, 3, 4. I'm doing it this way because I want you guys to see that it's a matter of choice whether you spread it out or not.
Is that how you spread it out?
It's up to you. Okay? It's choice. So now, the first point, that's the midpoint between 0 and pi. How much is it? Pi over 2. The blue, yes, it's half of that, so pi over 4. Yes. And the green, if you like, that's the halfway point between pi over 2 and pi. So that's half of 3 pi over 2, 3 pi over 4.
Wait, you did that really fast.
I know. Let's do it slowly. Look, I know. It works in this case if it starts from 0. If it starts from 0, whatever this is 3 times that, because it's like 1, 2, 3 spaces. But are we all in agreement that it's halfway between pi over 2 and pi?
Yes.
Okay, so now look. This is half of, and what's my trick? If I have a whole number and a fraction like I have here, the denominator is always going to be the same, 2. So now, remember what I was doing before. 2 times pi is 2 pi. Remember, I add that way, I multiply that way. 2 pi, and then I add this way. So 2 times pi, 2 pi, plus another pi, 3 pi. Of course it makes sense, it's math. So then this is 3 pi over 4. Okay, I'm graphing a cosine. Do I start from 0 or maximum minimum? Maximum minimum. In this case, where do I start?
2.
At 2. See, we're experts at that part now. And that's the easier part now. So that's a 2. Then 0, minimum, 0, maximum. Right? And if this, so yesterday we were going from 0 to 2 pi, right? It was going to be much wider, but now it's narrower. Okay.
Is it okay if I did mine like?
Yes, yes, absolutely. What I look for when I'm grading is, do you have 5 points and are they the right values? Okay, frequency. So we now know what period is. Period is how long it takes for one cycle to complete. Frequency is sort of the opposite of it. Suppose you were standing right here and there was like a glass floor and underneath you there were all these waves passing by. And suppose you were there with a timer and you were going to time how many waves, how many peaks pass underneath you in 1 second. That would be frequency. So now, if you had a function, I'm sorry, if you had a wave that looks like this, suppose you had a wave that looks like this. Okay, this is wave number A. And suppose you had a wave that looks like this. We'll call this wave number B. All right? In 1 second, are you going to get more peaks passing by you for A or B? B. B gets more peaks. That means it has a higher frequency. Yes, it's physics. Which one of these has a longer period? A has a longer period. It takes much longer for it to complete a wave. So higher frequency, shorter period. Okay? Again. Okay, so how did we find period? 2 pi over B. Period is 2 pi over B. Guess what frequency is? B over 2 pi. It's the reciprocal. It's just the reciprocal. It's a freebie on your test. Once you get the period, flip it around.
For frequency?
Yes. So here, what's the period of that first wave? 2 pi over 1, which is 2 pi. So the frequency is 1 over 2 pi. What's the period here? 2 pi over 4. Pi over 2. What's the frequency? 2 over pi. Please, please, please. I will always ask you this after the period on a test or a quiz. Use that to get a freebie. Okay, that's my freebie point question for you. Okay, now, you know how in these boring ones, everybody started at 0? Yeah. Never, ever, ever do they start at 0. Never, never. Okay? All right. Often, things have shifted in left or right. When it comes to trig, so all other functions, we call it a horizontal translation. In trig, we call it a phase shift.
That's so much cooler.
I know, right? A phase shift is when something shifts horizontally. No asymptotes. It's just saying that it's shifted, like this point shifted to this point. Okay. Phase shift moves the graph horizontally, either left or right. Okay, now, if you want to figure out how many spaces it's moved, I'm not going to tell you to memorize a formula. I'll tell you what to do in a second. Okay. Yeah, it's the same. So look at this function. What's the amplitude? 2. What? Okay, so period is 2 pi over the number in front of the x, which is a 1. So it's just 2 pi. No, because it's just the number in front of the x. Frequency is what? 1 over 2 pi.
And then you do the x over the...
Okay. Phase shift. Phase shift, here's what we do. We take this Look. We take that, that's the magic term, set it equal to 0, because mathematicians love nothing more than setting things to 0. So here, what's x equal to?
Oh, pi.
Pi. You know what that means? This moves to the right pi units. So is it going to start at 0? Not going to start at 0. Yeah. So here's how we figure out where to graph. 0, 2 pi. Same as before. Guess what we put in there? The whole darn thing.
Kidding?
Not kidding. Anything that comes after the sign. Okay? Yes.
Can you also, for this shit, can you just put, no, this x over, pi over the x?
C over B. But students, that's too much. It gets to be too much to remember. Setting it equal to 0 is usually easier to remember. Okay. So now, if it's x minus pi, how do I solve for this? Add pi to everything. It does make sense because it's math, right?
X always have to be by itself.
Yes. So now, pi x 3 pi. Okay. This is the start. This is the end. Okay? Now, we added pi, remember? Plus pi, plus pi, plus. Okay. Here's what we're going to do. Now, we're going to put this on the graph. All right? So, I'm going to start at pi. 1, 2, 3, 4 to 3 pi. Okay?
It's always 5 points.
5 points.
The middle.
Now, the middle, again, it's the middle of pi and 3 pi. I add them, divide by 2. Do you have to write out this whole long thing every time? No. But if you did have to, that's how you would do it. So that would be 2 pi.
In the middle of that is 2 pi over 3.
The middle of that is
2 pi over 3.
it? Yeah. So let's see. This point is half of pi and 2 pi, half of 3 pi, so that's 3 pi over 2. Okay? The other one is half of 2 pi and 5 pi, 3 pi, 5 pi over 2. Okay, now, here's a question for you. It starts at pi, ends at 3 pi. How many spaces are in between? Like how many units? From pi to 3 pi, what's the distance? 2 pi. What was the period?
2 pi.
2 pi. Do you see that? The distance from pi to 3 pi is 2 pi. This is 2 pi. So that's a way to check yourself. Okay, now, the period of this is sine. I'm going to start at 0. I'm sorry, the function is sine, but the amplitude is 2. So 0 up to 0 down to 0.
Oh, there's no line.
Where is the y-axis?
It's like back there.
Back there, where back there?
That's 44.
If this much is pi, right, then it's here.
So it's like right on the edge.
Would you also draw the not the face, like the regular starting from 0? Because
Yeah.
at the top,
Yeah. No, just this one. Okay? So do you see how instead of starting at 0 here on the line, on the y-axis, we started pi units in. And we knew that. We knew that we were going to start pi units in.
But like since it's a sign,
Okay, let's do this last one. Yes.
and like you know when you like graph the
Uh-huh.
sign, it doesn't start in the middle and that's
Right.
since it's a sign, it's
Yeah.
like you
Yes.
just start always on the first.
Right. Always start on the axis. Okay, this one's more of a... Okay, what's the amplitude?
4.
4. Okay. For the period, look, what am I going to do? It's going to be 2 pi over something.
2 pi over x over 2.
Right. So, but we can't take the x, right? So another way to write this is 4 cosine. This is half x, right? This is another way of writing it. So x over 2, I can rewrite it as half x. So this is 2 pi over a half, 4 pi.
You don't add the
No. Okay, now the frequency is 1 over 4 pi. Okay, phase shift. I take x over 2 plus pi over 3 equals 0. Okay, now watch. It's x over 2 plus pi over 3. So minus pi over 3 minus pi over 3. X over 2 equals negative pi over 3. Multiply by 2. X is negative 2 pi over 3. Okay, let's figure out where we're going to graph this.
So is that our phase shift? Is that the answer?
Yes. 0 to 2 pi is what I bound these in. And inside I put this whole thing.
why is it 2 pi?
Because it was always going from 0 to 2 pi, right? So look back, every single one, because the default sign goes from 0 to 2 pi.
Wouldn't it be 4 pi?
No, you always go default. You always go default, the default sign. Okay, so here, x over 2 plus pi over 3.
Oh, you don't put in the phase shift.
No, this is what we're putting in. We put in everything inside the parentheses. Okay? So now, watch this. I'm going to subtract pi over 3.
Let's say pi over 2 or
X over 2.
Yeah, x alone.
Yes. So here I have negative pi over 3. X over 2. Okay, now, hang on. This was pi over 3 minus pi over 3. Look at how I do this. Whole number and a fraction again. Denominator is going to be the same. So here's what I do. Multiply this way. You get 6 pi minus 1, 5 pi over 3.
It's not negative?
No. You just go with where the sign takes you. Now, multiply by 2, by 2, by 2. Remember, we have to get rid of everything next to the x. So I get negative 2 pi over 3, x, and 10 pi over 3. This is one of the more complicated ones, but it's not going to get more complicated than this. Let me finish this and then I'll take questions. Okay, we start at negative 2 pi over 3. And you know what? I'm going to spread this out a little. 1, 2, 3, 4. And go to 10 pi over 3 just because there's more to write. Okay. That first midpoint in the red, that's half of negative 2 pi over 3 and 10 pi over 3. So that's half of 8 pi over 3. And that's 4 pi over 3. Okay? So it's always these two, you add, you divide by 2. This, right now what we're doing, this is the algebra 1 or pre-algebra part. Okay? If you forgot this stuff, let's go over them during bonus. Okay, now, look at this one here, the blue one. That is the halfway point between negative 2 pi over 3 and 4 pi over 3. So do you see the reasoning here?
Yeah.
It's just a lot of work. That's it. You hit it. Yeah. So now when I add these, same denominator, negative 2 and 4, that's 2 pi over 3. So that's pi over 3. We canceled the 2's. The green is the halfway point. Class is almost over. Let me finish this. Of 4 pi over 3 and 10 pi over 3. So that's half of 14 pi over 3, 7 pi over 3. The math, okay, so now it's almost over. We have a cosine here. Starts at 4. 1, 2, 3, 4. Boom. Negative 4. I just did that. Yeah, 1, 2, 3, 4. 0. And then back to 4. So this looks like this.